Now, very often in C++, we find ourselves looping using a numerical counter. So, for example, you might want to do a loop as following, where you have a counter I, which you're initializing to 0. Then you have a while loop, and you're incrementing that counter in the body for every iteration of the while loop. And you're using a Boolean expression like this to check for the end condition. Now, this can be more naturally and succinctly expressed with a for loop in C++. So, for loop looks like this. You have a new reserved word called for. Then, within the parentheses, you have three parts. The first one, you declare and initialize your counter variable. The second one is a Boolean expression that checks the end condition. And the last one is uh, the update statement where you increment the counter. And then you have the body, right? So, in a generic sense, the form of a for loop is as follows. You have the for keyword. Within parentheses, you have the three sections separated by semicolons. The initialization, which is executed once at the start of a for loop. Uh, there is a conditional, which is checked at the beginning of every iteration. And there's the update, which is executed at the end of every iteration. Right? Now, do note that the body is a statement block in curly braces. If you only have a single statement like before, you can skip the curly braces. Right? So visually, this might look something like this. You start, you execute your initialization section of the for loop, then you test the Boolean conditional. If it's true, you execute the body of the for loop. And at the end, you do the update statements to update the counters. Keeps on doing this while the Boolean expression is true. As soon as it's false, you jump out of the for loop, right? So let's rewrite our factorial example that we had talked about earlier using a for loop. So here it is a very short for loop. We are initializing n, which is the n factorial is what you want to calculate. Factorial holds the resulting value is initialized to 1, and you are basically initializing your counter to be n, and you're decrementing it at the end of each iteration, and you're making sure that it stays above 0. And in every step, you're multiplying factorial with this augmented multiplication statement with the counter variable. And at the end, just print the result. So very, very concise, right? Now, do note that you can have multiple counter variables, right? And multiple update statements. You just have to separate them by commas. So here's what it would look like if you had two counter variables. You would, initialize both of them and separate them with a comma. You would still have your conditional end expression, and then you would have update statements for both, and you would separate them with a comma. Now we know of three different loop constructs. There is the while loop, there is the do while loop, and then there's a for loop. Which is the best? The answer depends on what you're trying to do with your program. Different constructs fit into different solutions that you might have to the problem. You'd want to use the one that's the most natural. Now, with looping constructs, we do sometimes need to either skip an iteration or interrupt the whole loop. So, how would you do that? So, let's talk about that. We have a statement called continue that can be used to skip the current iteration and go on to the next iteration. So, let's talk about an example of where would you might need this. You might have a string, right? And you might want to go and look at each character, but you're not interested in the spaces. You're interested only in the non-space characters. So you would create a for loop for it like this, where you initialize a counter variable. You'd want to loop to for the whole length of the string, and you'd increment your counter variable within the body. you might want to check if is the current character a space. If it's a current is a space, then you would do continue and you just go on to the next character. That's a good use case. Another statement we have is called the break statement. This ends a loop altogether, right? So let's look at example of that. Here you might have a string, and you just want to make sure that all of them, all the characters in the string are alphabet characters, right? And if you find something that is not an alphabet character, you just want to get out of the for loop altogether, right? So again, you have the for loop going over um, the string. Now you use is digit to check whether the current character is a numeric digit, represents a numeric digit. And as soon as you find it, you want to say something's wrong. I'm just going to get out of the whole for loop. So you just call break, and that ends your loop. Now, do remember that to get out of a whole program altogether, you would call exit, right? That's what you would do. Now, there are a couple of pitfalls to using for loops. Do remember from if statements that having using floating point comparisons can be a pitfall because floating point numbers don't have exact values. And if you have a comparison like this, d not equal to 1.0, you might find that this is you would get an unexpected result because it might be very close to a 1.0. It might be 0.99999, or it might be 1.00001, something like that, right? So avoid using floating point numbers for exact comparisons. The other thing you have to watch out for is off by one errors, where you stop one iteration too early or you pick up an extra iteration. That often happens when with strings, when you do something like this. You have to make sure that you uh, you stop before you get to the end of a string. So if you use a comparison like this, where it's less than or equal to a length, you'll be picking up an extra character at the end, and you might crash or get some garbage data. Now, we can have loops within loops. So you could have a nesting where you have three for loop nested um, within each other. The thing you have to be careful about, that this has an exponential performance penalty. So in this example, if you have statement S1, now suppose this takes 1 microsecond to run, so that's 0.000001 seconds um, here. Um, the whole code here will take 227 hours to complete. So the growth can be exponential. Lastly, I do want to mention that if you are iterating over strings, the for loop is a really good loop construct to use because you will see this pattern when you are looping over strings. You would initialize a counter, you would check for the end of the string, you would increment it, and then you would index the text um, somewhere in the body of the for loop. All right.